So we're up and running with example number 2 here, and we've been told about the prices in pence for a litre of fuel at 6 rural petrol stations. Rural means out in the countryside. And in part A we've been asked to calculate the mean and the standard deviation for this sample. So the mean is represented by x bar, and it's calculated by adding all the data items together. So sigma x, we call that, divided by the number of data items, which is n. And in this case, sigma x is 711. Of course, good to write that because we're going to use sigma x, this 711, we'll use that later on, and divided by 6 in this case for 6 petrol stations gives us a mean of 118.5, and that's measured in pence, just as the original data was. So on average you can say that the rural petrol stations charge 118.5 pence for a litre of fuel. Now the standard deviation is calculated using the formula that's given to you in your formula sheet, and that is sigma x squared minus sigma x all squared over n, all divided by n minus 1, and all living under a great big radical. And then I find the best way to do this is to build up the components needed in this formula. By that I mean work out what sigma x squared is, and work out what sigma x all squared over n is. So first of all, sigma x squared, the way to find that is to take each x value in turn, square it and add it to the square of all the others. So 112 squared plus 114 squared, 112 squared, and so on and so on, and that will give you, in this case, 84,881. You don't need to show working for that, but you do need to show this sort of interim value. And then the next thing for me would be sigma x all squared over n. And the reason that we wrote out our working carefully in part A was because we know sigma x is 711. So we need 711 squared over 6 in this case. Again, you don't actually need that step of working, it's just the interim total that you need. 84253.5. So as I said in an earlier example, these are always quite close to each other, at least. They're both sort of 84,000-ish. And then we can go back to the main formula and substitute these numbers in. So our standard deviation now is going to be equal to sigma x squared, which is 84,881, minus this thing, so sigma x all squared over n, so that's 84,253.5, all divided by n minus 1, which would be 5, so 60 per 1 is 5, all under the radical. And then you can key that into your calculator, just make sure you're careful with it. You'll get 11.202 stuff, which we can round off to 11.2. Remember, standard deviation is measured in the same units as the original data was, so it's 11.2 pence, and that's 3 significant figures I've rounded to. So what we can say here is that on average, a litre of fuel in a rural petrol station will cost 118.5 pence, but you can expect there to be some sort of variation from that price, and on average the petrol stations will vary by 11.2 pence, either up or down from this. It doesn't actually mean there'll be any petrol stations which are exactly 11.2 pence more expensive or less expensive than that, but on average all the petrol stations for this sample vary by 11.2 pence from that mean value. So in part B we've been given a little bit more information. Similar sample of 6 urban meaning in the city, petrol stations produced a mean of 114.5 pence and a standard deviation of 5.5 pence. So what we can see here is that on average petrol in the city is 114.5 pence, whereas the petrol out in the countryside is 118.5. So when we're asked to make two valid comments, one of them will certainly be about the average price. And there's two ways of saying it. On average, the rural petrol is more expensive, or on average, the urban petrol is less expensive. Doesn't really matter which one you go for. On average, the rural petrol is more expensive, and we need to justify that. So what helped us make that decision? Well, it's because 118.5 is greater than 114.5. That's our first comment. And then we'll need to think about the standard deviation. In the city, 5.5 pence is the standard deviation, which means that you can expect the price of petrol to vary by about 5.5 pence as you go from one petrol station to the next, whereas out in the countryside our standard deviation is 11.2, so much more variation in price out in the countryside. So our second comment will be something to do with how consistent the prices are. And then I think I would probably say that the urban petrol stations are more consistent. So the price at urban petrol stations is more consistent and then again we're justifying that by saying that in this case 5.5, that was the price for the urban petrol stations, that's the standard deviation, that's less than 11.2, so that's our justification. There is a third part to this question, an interesting one really, part C, because we're told that the following week the prices at each of the stations increased by 4 pence. So that's all the stations that we've looked at, they've all gone up by 4p. And it says here, describe how the increase affects the mean and how it affects the standard deviation. If you think about it, you add 4 pence onto each of these, then that's going to be 6 4 pences that get added on, and then you're going to divide that new total by 6 to recalculate the mean. You don't actually need to recalculate the mean, because if you have 4 and you multiply it by 6 and then you divide it by 6, then you're going to get back to 4. So we've effectively added 4 on to the mean price, and that would be the same for the urban petrol stations as well. So if you add the same amount to all the prices, then the mean will go up by that amount. So in part C, part 1, the mean will increase by 4 pence because the average price has gone up by 4p, because they all went up by 4p. By 4 pence. The interesting thing here is what happens to the standard deviation, because the standard deviation is a measure of how spread out the prices are, and because they've all gone up by 4 pence and the mean has gone up with them, then actually they're still spread out to exactly the same extent as they were before. The prices haven't moved away from the mean, everything's gone up by the same amount. So what we can say here is that actually the standard deviation, better just to write it out in full, but you can abbreviate standard deviation, but let's write it out in full. Will be unchanged, and that's because standard deviation measures spread or consistency, and that has not been affected if every single price went up by the same amount.